Hello and welcome to the day 6 of the Advent of Code. Let's start by reading the statement. How many characters need to be processed before the first start of packet marker is detected? Okay, we need to find out what this start of packet marker means. But we see there's only one line in the input, so let's copy it as a string. So maybe we don't need to do any input. So what is the start? To fix the communication system, you need to do a routine to detect the start of packet. In the protocol being used, 4 characters that are all different. Okay, so what we need to do is for I in range len of s minus 4, minus 4, if si, well, if the length of the set of s from I till I plus 4 equals 4, then this is the start of the packet. Before, so I guess the result print I break. Let's see if this is right. I don't like the linting of this. Okay, I don't know. Let's submit it directly. Okay, too low. Maybe we got something wrong. Let's copy some example. So if we take this as the example, I said the solution is 3, but this is not right apparently. So 1, 2, 3. These 4 are all different. J, P, Q, M. So that would be correct. Okay, maybe it is detected in the end. So instead of I, it is I plus 4, right? And then we get the 7 that we say here. So think maybe that is what we needed to do. We needed to read until the end of the character. Okay, too recently, 8 seconds. Submit, 2 seconds. We got the gold star. Okay, we will later comment this, but let's go for the second part. How many characters it was before the first is detected? Okay. It's just like a start of packet marker, except it consists 14 characters rather than 4. Okay, so this is just n equals 14. So is this right? Is this what we need to do? Okay, we are right. So today was very quick to get a solution. I didn't pay attention to the example, so I didn't know that we needed to read all of the until the end of the packet, let's say. So I guess we could create a function called what's it called? Start of message marker, find marker, or how could we call this function? Def first sequence of distinct characters. Is that what we can call it? So S is the string, N is the number of characters we want to return. So we could have this, we copy it, and instead of this, we return I plus N, right? So here, part 1 and part 2 are assert first sequence of distinct characters of S, and we could also include S as the input. Here I don't like that this long string is just messing with our linter, I don't know what the issue is. I guess this is just too long a line. So maybe I will just delete this file, edit 6.in. Sorry. Okay, so it was good to just paste the string into the input to go fast, but now I'm going to read it. Okay, so it will be open 6.in dot read dot strip. So now we have the text, and then this is the text, or we could maybe this is a message. We could call it message. So let's read input part 1 part. So here we are sending the message, and this is length 4, and this is length 14. We said that we need to assert that this second part equals this, and the first part equals this, 18, 16. Let's see if this is right. Okay, yeah, the asserts pass. So the only thing we could refactor now is this. We could change this to message also. We could refactor maybe this function. What we are doing here is we're iterating from the first character till the length of the text minus n. And inside it, we're checking that all of these n contiguous characters are different. This is not the most efficient thing, so probably there is a better algorithm. There's probably a better algorithm. I'm trying to think if there's some kind of keeping track of, so inspecting like a sliding window of n characters and checking if there is anything if there is any repeated character, but maybe, I mean, for this input and for the purposes of this problem, I think this is a good enough solution. So the idea is that we're iterating from I till length of s minus n. And then we take the substring from I to I plus n, and we check if the length of this set is n. I think this is good enough. If there was more than one repeated character, we could skip one index, but this is not necessary. And here, of course, we could also say assert false, for example. So we want to make sure that this never happens. So, well, I think today it was a very, very quick problem to solve. I like this solution. Length of set, I don't think. So this is a very quick way of checking that all characters are different. You do a set, so you get all the unique elements. You check the length, and if the length equals n, then it means all of them are different, right? Okay, so let's talk about the lessons learned. Today there weren't many lessons learned, I guess, because it was a pretty simple problem. What could we say? One, well, we were quick by pasting the input made as in the Python code was fast. That is one thing we did. It's pretty easy, but then what really was the interesting thing is that we check that all elements in a list are different with the following trick. So if L is the list, we do the length of the set of this list equals the length of the list, right? So this, if this is true, then all of the elements are different. Other than that, we just reuse the same code. This thing we added in the end, so assert false, that is a way of checking, making sure that some part of the code is not reached. So we can do that to prevent this weird case in which we would not return anything from this function. And then, well, of course, we refactor this, we factor this I don't really like this name because it's what we are not returning is the first sequence of distinct characters. Let's say it's the index where first sequence of distinct characters is detected, right? This is what we are. It's a very verbose name, which would summarize the problem. But it is what we are really computing. So I think it is useful to have this name. Anyway, it's a very, very short problem. Okay, I hope you like this solution. Today was an easy problem. Let's see tomorrow. Bye bye.